Hello everyone, welcome to today's webinar brought to you by Microbial Insights. Today we are going to be talking about sustainability and groundwater remediation. So we appreciate that you are taking the time to join us today. It is my pleasure to introduce our esteemed speaker, Dr. Yu Rong. Dr. Yu Rong is the Environmental Program Manager at Los Angeles Regional Water Control Quality Control Board for leaking underground storage tank sites and water quality monitoring program in oil and gas fields. He has more than 35 years of experience with the agency in dealing with groundwater contamination problems in the Los Angeles area of California. Dr. Rong earned his PhD in Environmental Health Sciences from the University of California at Los Angeles, otherwise known as UCLA, and recently was adopted into the Hall of Fame of UCLA Fielding School of Public Health. So now, before I let Dr. Rong take it away, I would like to remind you all, as always, that this webinar is being recorded and will be available in the resource section of Microbial Insights website, hopefully by the end of today, if not by the end of this week. So don't worry, we'll also be sending out an email with a link and certificate of attendance following this webinar for those that have registered. And there are also some included informational handouts you can look at during this webinar. If you go to your sidebar under the handouts section, we just have a couple of handouts you can view. So after he is done, there will also be some time for questions. So feel free to type your questions as the presentation goes on. And I'll try to read off as many as I can when that time comes, so you can get your answers. So join us in welcoming a true advocate for sustainable solutions, Dr. Yu Rong.
Thank you. You guys can hear me, right?
Yes, we can.
Okay. Very good. Well, thank you. Thank you so much, Marshall, for the introduction. Good morning, everybody. Here's my first slide. Hopefully, everybody can see it. The subject today is sustainability in groundwater remediation, which we gained some experience in California, where I work. Here is the outline for today's presentation. I just want to take the opportunity to thank the Microbial Insight for the invite. It's a good opportunity to communicate with people across the country. Hopefully, some of you have some experience working in California. Okay, here's the outline of the presentation. We're going through the sustainability definition. You know, sustainability is a pretty fashionable word those days, but each field they have different definition, I think, in terms of what is a sustainability. So we're going to discuss that with respect to groundwater remediation. Okay, then we're going to talk about the three factors: environmental, economical, and the social indicators in the sustainability. We're talking about the environmental factors, risk assessment, environmental forensics. We don't have too much time to get into it, but I just want to touch bases very quickly. And then we'll talk about site remediation cost analysis, which I did a little bit analysis. And the remedial methods, sustainability analysis, I will go through a couple of the common used remedial methods. And if I have time, and I'm going to share one case study, reuse of a remediated soil. All right, for those of you who are not really familiar with California, here is just a very quick going through with the California regulatory hierarchy. In California, we do have a EPA, just like a federal and the Environmental Protection Agency. And within the California EPA, there are the 6 departments. One department, first one is for water, second one for air quality, third one for pesticide regulation, and the fourth one is toxic substances control. And the next one is called recycle, and the last one is the environmental health hazards assessment, and we call this office OEHA. That's pretty much doing the human health risk assessment. Oh, I'm sorry. Jump too fast. Okay. With respect to groundwater remediation, that jurisdiction going to regional water quality control board. We mentioned in last slide, in Cal EPA, there is a water quality control board, water resource control board, and there is 9 regions within California. That region divided by the watershed. And I work in the region 4, Los Angeles. And if you see the map, we're in a very small geographic area, but it's because it's a very industrialized. So there are a lot of pollutions. So a lot of work. Some of you may have experience and come for California to do the environmental cleanup. That certain areas you probably go more often than others, and LA is one of them. Okay, well, quickly just give you some perspective regarding the state of California. People talk the most is the budget, the money, right? So you probably heard about this from different area that California, if California is an independent country, their GDP probably ranks in the number 5 in the world or number 7, somewhere between 5 and 7. So here is our annual budget. So that's a 288 billion. But I just want to show you that the budget pie. If you see the big chunk, the first one is for human health and human services. That takes a lot of a budget. And the second one is really for the education, from the K to 12 education. And here is the third largest pie is really for the higher education. So if you add all the 3 together, it takes about 75% of the total our budget. Although we have a lot of money, but most of the money is spent on really your health insurance, your kids' education, and also the college education as well. So if you look at, I think our environmental protection, the 1.9%, is still pretty high percentage if you take perspective, because give you a comparison, I think in the federal level, there is a National Science Foundation for Research Fund, right? That's about 2.2% of total federal budget. So it's in that range. It's considered a lot of money to devote into scientific research from the federal level. So in California, you can see the environmental protection, we devote about 2% of the total budget. So it's a lot. All right, so let's get into the subject. Definition of sustainability inside remediation. I did some Google search, and there is a definition offered by SURF. Some of you may heard about this organization. That's I think a sustainable remediation forum. That is a sort of a NGO organization. So the definition they define as the practice of demonstrating in terms of environmental, economic, and social indicators that the benefit of undertaking remediation is greater than its impact, and that optimal remediation solution is selected through the use of balanced decision-making process. It's a long definition. That's a definition of sustainability in terms of site remediation. So if you can summarize that long definition, that's pretty much that definition has the 3 points. One is environmental, economic, and the social elements, and you have to consider the three elements. And the second point is the benefit of a site remediation outweigh the impact of the pollution. In other words, it's worth doing it. If you have a very minor pollution, for example, then you spend a whole bunch of resources to clean up the minor pollution, that will not be worth it, right? So that I think that point is the benefit of the remediation you're doing has to be outweigh the impact of the pollution. The third point is there has to be a balanced decision. That's really implied the environmental versus economic growth. And this is a sort of a conflict, right? So you want to, for us, our Cal EPA, we would like to spend more money to do the environmental cleanup. But on the other hand, for the manufacturing, they would like to have their economic growth as their preference or their priority. So there are 3 points in the definition. So there are 3 factors, and there is a benefit doing the cleanup, and also there has to be a balanced decision. All right, so this figure I borrowed from my friend and Ravi Randasan, and this is the perfect word. Making the circles, there are social, environmental, economical. We're talking about the 3 factors, and they're sort of overlapping. And right in the middle of it, that should be a sustainability. That's a sort of a graphic explanation. But I have to say, this one is a sort of a ideal, right? It's a perfect word, perfect circle, perfect interaction, perfect overlapping. All right, so let's coming back to put our thought into the framework. Once the remediation goal is set, can we sustain? This is a question we're doing, cleaning up a business. Everybody try to answer, right? For the consultant, for the environmental consultant, this is the primary questions we have to get answer. Second one, we'll talk about the 3 factors, environmental, social, economics. Nowadays, they call the ESG as the environmental, social, and the governance. The governance, including primarily the economics, right? So the balancing the budget, and you don't spend more than your spending goals. Next bullets, clean up benefit outweigh the pollution impact. We'll talk about that. And balance decision and clean up versus the economics. We'll talk about that too. Then limited resources, no matter what we do, the resources always limited, right? Your human, the money, your staff, those are all limited. And of course, the current technology is more important, play the role in this sustainability. You have a better technology, you're better be sustained. Okay, environmental remediation method, and just very quickly, I think most of us already know that the physical, chemical, and biological, and there are common certain used the most. At least I have seen in California are those, soil vapor extraction, in situ treatment, and monitoring natural attenuation, and phytoremediation, many others. And we can talk about that during the Q&A. All right. In terms of that 3 factors, environmental and the social and the economic, and we're going to, in this presentation, going through their analysis for the certain method. Those methods are listed here. We'll go through very quickly and see how that relate to that 3 factors. All right, this table I made up. It's a sort of a summarized remediation evolution in the past. And 60 years ago, and remediation really means it just throw away 30 years ago, and the remediation progressed a little bit, and that means dig, pump, and bury or burn, and just sort of try to do something. Nowadays, and we're emphasized on green technology, we're emphasized on recycle, reuse, and the natural attenuation, biodegradation, and so on and so forth. That's turning little green those days. Okay, let's talk about the social factor first. And this presentation is not about that social factor. Actually, social factor, we can have another class. We can talk about more. And this picture are taken in our region, in LA areas. That's a real case I have been dealing with. So if you're doing remediation not approved by the residents around, and you will run into some trouble. I think some of us probably experienced that. So people put their signs there, and the people demonstrate things like that. And another factor, another aspect of this social factor is they have sometimes they have a demand, and this picture showing the sun, sort of a sun barrier for the house they're surrounding. We try to do some work, outside on the street, and the residents are complaining, and they're asking for the sort of a sound barrier. It's not a complete barrier, probably, reducing some decibels for when you're operating the heavy machine. So this one is pretty big because that's increase your budget a great deal, right? So the social factor is very important. All right, this is the case I just showed you a couple slides ago. This is a house built on refinery waste dump pit, historical dump pit. So this caused a lot of problems later on. At the time they're building the house, they're not really recognized that the refinery waste can be hazardous waste. So nowadays they have to, the oil company coming back to dig the dark soil out and to meet the residents' expectations. On your right-hand side of the slide, you can see they have to sort of remodel, replace what they have digged out and on the surface, and that house on the top is before they're doing excavation, and that house, same house, and below. You can see the front. They completely renovate. So that's the social factors sometimes is very costly. I think that's a point I want to make. All right, so let's do some cost analysis. And I work in the LA area, so I pick some cases and look into their cost. And I pick 179 underground storage tank cases that closed, which means they finished their cleanup for the last 20 years, and find out the total cost is about $1 million per site. All right, so let's look a little bit further. This slide just shows the statistics of that 179 cases. I know the average, the maximum, the standard deviation. You can see standard deviation is not that big. So we're pretty much, I think the average pretty much represent the average cost across the whole region. All right, so this slide is showing the pie chart of different type of remediation method. I summarize on the lower part, right-hand corner. I summarize the top three technologies, the top three pie in the pie chart, 1, 2, 3. The first one, the soil extraction, soil vapor extraction. That's used the most. That's I say top three that's the most frequently used. The second one, the dual phase extraction. The third one, the free product removal. This is a summary of remediation in the underground storage tank site. Okay. All right. So to give a summary in terms of each method, a cost. So here is the summary table. Soil vapor extraction, for example, the average cost is less than $1 million. So per site. So for the 74 site, I'm tallying it up. So if you see, most expensive one is the soil excavation, right? The third one. So that's the most expensive one. All right. So here's the sort of a summary for that average $728,000 average. We compare with each remedial method, soil vapor extraction, dual phase, and we find out the soil vapor extraction cost is lower than average, and the dual phase is lower than average. However, if you want to do soil excavation, that would be higher, and pump treat higher, and the free product removal is lower. That's a sort of made a comparison. All right, with all of this, social things, we'll talk about economics, and then let's talk about the each method a little bit. For soil vapor extraction, if you use that's the three factors to do your analysis, you will find out some pros and cons. And I think most of people here, I think, is pretty much familiar with this method, and I don't have to go through the details. The last arrow you can see this method is a little bit noisy. This is a really social factor, right? So if it make a noisy and people surrounded and complaining, and we'll have to do something. So that's a certain way, environmental and social and also economical. You can see the cost is moderate. So we compare with in our region, that analysis will find out that the cost is below average, right? So if you still remember last slides. All right, for soil excavation, of course, it's a little bit costly, and it's interruptive. Interruptive can be considered as a social factor as well, because people, you can see the picture. There are some business around here. If you have a huge hole right here, people will not like it. So, but there has some advantages, and for the fine-grained material, for example, excavation is more effective than soil vapor extraction. Okay, here's the dual phase. Dual phase is more effective. Particularly, people use it to clean up the capillary fringe, right? So I don't want to spend too much time, because I think most of the people here are very familiar with those methods and the pros and the cons, particularly. Groundwater pump and treat. This method used less and less as far as I see, because I think it takes too long. So if you put this method into that three-factor analysis, you can find out and the pros and the cons. There's a major problem we have with as a water board is most of the people, they pump the water out, they discharge into a storm drain. So we think that's a waste of water. So that's why more or less we start asking them to re-inject back to the aquifer. That's or increased cost, of course. So this method I have seen people use less and less. Thermal treatment, I think this method is being used increasingly. Again, more and more people are using it. This one has to be most effective combined with vapor extraction, right? Soil vapor extraction. That's good for the fine grain material. If you got a sandy material, of course, vapor extraction is sufficient. And if you have a little bit, silt, a fine grain material, and this one will help to evaporate the volatile things. Of course, the the energy consuming and the cost is a primary concern. This method, another thing is interactive. Why interactive? Well, when you put all of this heated pool in the site, you have to circle them out. You just can't let people to walk on the surface, right? So that's interactive. You cannot do anything else once in the process. Okay, in situ treatment might be the most popular ones those days. They inject chemicals and biological agents into the aquifer to have interaction with the pollutant compounds. Of course, if it goes to the three factors and low cost, saving water, selective interactive, all of those things, that's a good thing. The con, well, I talk about the pros. The con is this method probably only good for the polishing state of your remediation, your active remediation. So if you got the very high concentrations of contamination, you probably this method may not be work very well. Some cases you may demonstrate that's working, but most of the time people like to use in the sort of a moderate and a low concentration area. There are another concerns that people often relate that to us. That's a biological agent concern. Those are microbials. I know the Microbial Insights has pretty confident. Well, what they've been dealing with, it's pretty safe. But I think those microbials multiply very fast. If you allow them to multiply quickly, I don't know what the effect. So people are very concerned in that area. The most tough one for me is I'm talking about the con of this method is how to estimate the mass removal. This is very hard because I think we're being always reporting how much money we spend to remove how many pollutant, right? So how many pounds and or how many tons of the soil being removed, all of the things. But for the in situ treatment, it's very hard to estimate the mass removal. You can have your chemical equations to figure out how many mass you're injecting and how many mass can be interacted with the pollution compounds. But those are just a sort of a theoretical calculation. In reality, in the aquifer, their reaction is not like the reaction in the laboratory, right? So you have a lot of other factors. Therefore, the mass removal or the mass neutralized mass, it's very, very hard to estimate. So that makes, I think, people writing report pretty hard. So they just can tell you how much agent or chemical amendment they inject in, but they cannot estimate how much the pollution being removed. So that's a con, I guess. All right, monitoring natural attenuation, monitor natural attenuation is a method. Of course, EPA is being recognized as one of the cleanup means. That has some pro and cons I listed here. This one is the same thing. We'll probably use at low concentrations or and a moderate concentration situation. If you got too high concentration, that's not a very good choice. This is, of course, the advantage is the water conservation, right? You save water, you don't waste those water. The same thing as in situ remediation. It's very hard to estimate mass removal. You're not really removing; it's just sort of a diluting. So and pro and cons. Of course, the cost is put the money front is less. So people will think that that's a good choice. Actually, this method is the best choice in the situation when you have real physical constraint. You're not allowed to access the contaminated hotspot. That might be the only choice you have for this method. All right, so this one, we're talking about green technology. So this is really green. they use the green plants to remediate the contamination. So phytoremediation is it's growing. We just invite a company into our office to have a talk and see what the progress they're making. Of course, this is a very green technology. We're talking about green technology. We're talking about efficiency, saving energy, right? Using recycle, reuse, those kind of things. But this is green technology. This green technology really not only has all of that characters, but also the color is really green. So there are some good, pro and cons are listing here. The only problem is they're using the using the root zone to do the cleanup, but that's pretty shallow. So if you have a very deep groundwater, that will not work. So of course, shallow ones that will be a choice. I'm not sure that will be working very well, but that would certainly will be a choice. The cost is low, it's effective. I put an interactive here because I think next slide I will show. If you have you have to plant a whole bunch of a shrub or plants on the side. That really takes a lot of space. Okay, this slide, the courtesy of Intrinsics environmental, they're talking about, they did a lot of studies and what kind of plants, what kind of course, we encourage use a very deep root type of plants, so they can take the groundwater and also in the meantime take the dissolved phase contaminant. Okay, this is one example. This guy is about 6 feet, I think. So the root zone can be 6 feet and plus. If you can go a little, maybe the groundwater a little deeper, let's say 7 feet. That's encourage the root going deeper. But this kind of I don't know what kind of a species, but this kind of a plant is widely used to do the phytoremediation nowadays. You know, I think EIHS has a journal just called Phytoremediation. They're talking about that method. You know, people practice in this field. They're writing papers in that journal. Okay, this is a phytoremediation a case study, and it's coming from that company showing to us. If you, I think this the goal is to contain the contamination plume. So that's why they have this sort of a 90 degrees angle type of a zone to sort of contain that plume. Don't know about the result. They told us it's very effective. So that's another case study. They're showing, so this phytoremediation zone is also used as a barrier to contain the groundwater contamination plume. So all right, so that according to this company, and there's the pro and the cons, and increase of biomass tolerance. I think they inaccurate some agent to this plant, so the plant will grow stronger or prompt to taking more water from groundwater, that kind of thing. All right, so I went through those methods very quickly. I know most of us, I think in the webinar, you're very familiar with those methods. I just want to go through that method with that three factors: environmental, social, and economical. So there are some other methods that don't have time to talk about, and we have seen widely used. It's a PRBs. People are using to contain the plume, right? So then there's the modular horizontal wells being used to install the vapor, soil vapor extraction wells that we have seen more and more those days. For the areas like Los Angeles, I think the horizontal drilling has certain advantages because we're so populated, so many buildings, and it's not too many open areas can be used for installation of the remediation wells. And there's the in situ oxygen and the bioventing. This is very similar like in situ injection, but right now the bioventing is sort of separate with others. Incinerators right now, I think at least in California, use very little because I think the air quality permit is pretty hard to get in terms of burning something out. And the soil washing, of course, people still using. We don't have time to go through all of them. With that, three factors. Okay, let's coming back to our subject. So sustainability dilemma, how to set up cleanup goals. So when I start working with the agency as a junior staff, I've been facing the questions and how clean is clean. So 30 years later, and I'm still having same kind of question: how clean is clean? I think the clean goals, the cleanup goals, it's a moving, right? It's advancing with the people's understanding with new technology, right? So that's why we're talking about sustainability here. Clean it up to background level is certainly is a cleanup goal you can set up. Then it has to be cost effective. Apparently, there's both maybe conflict. Then there are the risk-based cleanup goals you can set up. Then the more important, I mentioned earlier, the public acceptance. So I mentioned it earlier. I think the public, if they won't prove your way you're doing business, that's very hard to implement. So this curve sort of showing mass removal to a certain point, it's going to a plateau, right? Going to flat. Then to a certain point, it's just you can get less and less. So the question to us, to regulatory agencies, to the consulting community, to responsible parties of the pollution side. So when you start stop your cleanup method, is the first Blue Cross or the second one? So that is a dilemma. That is a challenge to all of us. Okay, Marshall, do we have time? I think.
Yeah, you have plenty of time.
Okay, very quickly, I just want to have a case study to show how that happened in California, reuse of a remediated soil. There are the EPA guidelines talking about the reuse of water, so there's something in there. I just want to go through very quickly. The EPA guidelines is a sort of a calling for you got to specify the soil contamination. It's a petroleum, it's a metal, it's a volatiles, it's a PCE or something. Then you have to evaluate the exposure pathways. It's sort of a risk assessment. And the soil type and ecosystem functions and the reuse proposal, the required, right? You're going to use it. You treat the soil, then you got to reuse it. Then the permitting process right now in California, and where the agencies are issuing that kind of permit. Then of course you put in the operation, and after that you need to have a monitoring. This is the EPA guideline. Here is the example of we have in our regional board, and on the right-hand upper corner, that is the real document. That is the permit we issued in writing. In the permit, it was sort of like this. That's highlighted, put in here. The specific volume, the soil you can use, and the soil. Where's the soil coming from? That's coming from the oil and gas extraction field. They have a storage pond. You know the oil come out, right? They do the water and the oil separation in the surface. Those water being separated, they are put in the pond. Pond sometimes has no bottom, and sometimes they have clay at the bottom. But anyway, they put the water in there, then re-inject the water back to the deep layers where the oil comes from, right? So the soil they want to reuse only coming from the bottom of the pond. They cannot mix with the other part of contaminated soil or impact soil. Then also required to mix with asphalt and the concentration requirement, and mixing with other materials also specified. That's only used for the pavement of the road. And the oil and gas field is pretty big. Sometimes they need to pave the road. And the asphalt materials in the road, it's required 90%. This is a pretty tight, pretty stringent requirement actually. Then there's the permitting. They got approval in the permit. They need to hold the permit to proceed. That's just an example. So now I think I'm finishing my talk. Before I go, there is some something to think about it. Some thought, food for thought. So we're doing our remediation business, right? Soil cleanup, groundwater cleanup. The first question is that sustainable? What's it really sustainable means? And it has to be benefit, right? All the way what you're doing. You have to be a balanced decision. You have to consider that 3 factors, right? That's all in that definition. And then if you can reuse, recycle, that's great. And then has to be cost effective. Then has to be have a resource conservation in your mind. Reduction emission, that we're talking about green technology, that both are come together actually. And there's the most important ones, number 7, public acceptance. And if we're the public agencies, if you want to have a public acceptance talk, and we can have another class. So that's I think the bottom line is that you need to get the public, the residents around you support what you're doing. Usually they do, because you're doing a clean up of the environment. That's a good course. So here is my last slide. I'm finishing my talk. Well, thank you so much for your attention.
Thank you, Dr. Rong, for that amazing presentation. We're glad that you were able to wrap it up for the year for us. We do have a couple of questions, and if any of y'all do have questions that come to mind, you can either type them in the question sidebar as you think of them, or you can email info@microbe.com. We can get some responses to that. Our first one, so you can either mention one or a couple of these, but was there anything that sort of surprised you or you found insightful that you might have found out of these results in these case studies?
Which case study, the soil reuse or the remediation method?
The remediation one.
Oh, I think so. I think so. Yeah, I think your question is that insightful for doing the analysis in terms of helping to decide which method is the better one. Is that the question?
Yeah, just anything that sort of stood out to you or might have surprised you that you found.
Surprise happening every day. We're working in the office, there are always surprises. There is always something out of your expectation, really, seriously. But it's always good, we clean up a lot of sites, and we do a lot of soil vapor extractions, right? So once for a while, I think it's a good thing to sit down and look back and see what do we have, and doing the sort of analysis like this. Sometimes it's helpful, give you open your mind a little bit. So surprise, it's always happening. When I say surprise, we see the site, very good, sandy soil, very good soil vapor extraction candidate, and we started cleaning up and find out we're cleaning up forever. How come a couple of years later, so still doing it? Something wrong there. So you just have to do some analysis and see what's happened. So some site, and we finished cleaning up in 6 months. Some site, 10 years later, they're still going. So if that's a surprise, yes, it is.
That was a great answer to that. We got a few more. Does California require or have sort of a specific criteria regarding quantitative or qualitative green sustainable remediation goals as part of their remediation plan?
Very sadly, no. I'm not aware of any. I think the only thing we have is EPA, federal EPA's guidelines, and I think the guidelines encourage you, right? That there is no requirement encourage you, and that they reduce carbon footprint. We do, however, we do in California, we have a cleanup fund, right? So if you work in California doing the gasoline station cleanup, we have a cleanup fund. When you apply for cleanup fund, I think the green technology is being encouraged. So that's all we have. You are encouraged, and there's really no requirement. you must calculate your carbon footprint, or you must do certain things to reduce your energy consumption. No, I don't think there is something like that. But yeah, we're in the encouragement stage, I think.
Okay, gotcha. One person was interested in what happens to the plants in the phytoremediation after they have ingested all of those toxic compounds.
That's a question I ask those people, ask those phytoremediation company. I say, well, let's say TCE, for example, you extract, they take into their root, get into their trunk, and get to the tree leaves, they evaporate, right? So I guess that's a flow. Once they evaporate, I think the TC is going to into the ambient air. I would think, I don't think that there are any studies being done. Maybe it is. I'm not familiar with that phytoremediation journal. I would encourage, if you're guys doing that, please do. Maybe it is. Maybe they're released to the ambient air, but only in a very, I would think, only in a very little quantity. So the tree, the whole, the root, the trunk, the leaf, that system is sort of a serve as a absorbent. Just take them. Are you going to kill the trees? Maybe not. I don't think the concentration higher to that point. However, I do remember I asked them that question. The phytoremediation company told me once the project finished, they're going to cut off their shrub, take them away, take the root away. The company probably don't want them. They have to take them away. Take them away. I do not know where they go. They go landfill, or they chop them off like they do to the Christmas tree after Christmas. I don't know. I think that's worth exploring.
Thank you.
Sorry,
No,
may not be cool.
yeah, it's a very elaborate process to decide sort of what happens to them, and that of course is for different people to decide. We have another one. You kind of touched on this briefly. How can the remediation industry effectively balance sort of achieving that site-specific cleanup goals while having those larger sustainability goals, such as like reducing greenhouse gases, their emissions, conserving natural resources?
I know. Thank you. That's a very good question. I know some people are making effort right now, try to make a case. How you can do that? I think you have to work together with your regulatory agencies, work with your academic sectors together. I think in California, at least I have seen people start making the argument, making a case. What case? So that they compare with, you can clean up to, background level, but we all know that won't happen, because you can't take, once the site polluted, you cannot get 100% of the pollutant out, right? So we know that. So, but how much you can leave behind, that become argument. So then you have to make a case. So you save how much, resources, save how much energy, reduce the emission, reduce your carbon emission, things like that. And then make an argument. So maybe some academic support. And I think the regulatory sectors are open. So I think we are entertaining this kind of argument. So that's a good thing, moving toward that direction, though. because we'll have to deal with the climate change, for example. So this is a big subject. How to, as a part of the climate change concern, we need to reduce our carbon emission, right? So the carbon emission, you know, we're doing the cycling up, we produce some, that's a guilty part. But that's a good part is we're cleaning up the environment. We remove some mass from the environment. We are reserving our water resources. So that's a good part. So it has to be balanced somewhere. So I think eventually you have to boiling down to your case. This is a case by case argument.
Yes, indeed. And we'll do one more question. And guys, if we didn't get to your question, or if you have any other ones that pop into your head, you can just email info@microbe.com. Dr. Rong, if you could send over, once we finish, the presentation slides. I know we have a few people asking for that. So once we get off, you of course can send those over to me if you want. And y'all can just email info@microbe.com for them. So the final question, they understand that you've reviewed 179 sites or so to compile your cost data. What type of sites were those? Were those UST removal sites or other types of contamination sites?
Those are all underground storage tank, gasoline tank site. The reason I pick up only them because in California we have a underground storage tank cleanup fund, and we have GeoTracker. Those records are readily available. That's how I did the analysis. With the other side, yeah, a little difficult to compile those information. So those are USD side, underground storage tank side.
Gotcha. Thank you so much for presenting. It's been an honor for us to be in your presence as you went through this presentation. I know you have a busy schedule to fit us in, and we're thankful for that. And for everyone tuning in, we hope that you'll join us next time.
Well, thank you so much for inviting me, and also happy holidays to everybody.
Of course, happy holidays. Thank you so much.
Okay, bye.
Bye.